Hello everyone, welcome to this version of my video. My name is Blessing Taiwo. I'm a technical specialist at WipWare and I'm also a mining engineer. In this version of my video today, I'm going to be walking you through WipJoint, a new module included in WipFrag 4. So this module was originally developed in 1990 and was included in WipFrag 1 but discontinued in WipFrag 3. I'm going to be walking you through what are the results you can get from this module, how can you use this module, and what are the applications in blasting and also in slope stability assessment. Yeah, to begin with, we're just going to go through a typical discontinuity property. As you can see, discontinuity properties include the spacing, which is the distance between two almost parallel joints, as you can see here on the screen. And we have the infilling, which are the material that fill in the discontinuity. We have the roughness and wall strength of the particular interface. It could be the bench face. Then we have the block size, which is the in-situ block size, as you can see. Then we have the persistence, how continuous the joint is. You can see an example of persistence is the distance between this place, these points of the joint to this particular location, the persistence. We also have aperture, which is the opening size of a particular joint. Then we have about the orientation, the dip, and the dip direction. The dip is basically the inclination of that particular joint to an horizontal plane. So yeah, and basically, as you can see in this image, it's a scan line approach is being used. Note fully where there is another approach which is called a window mapping, but in this application, in this module, I'm going to be walking you through things that you can use the results of this module to do during your blasting, during your drilling, before the drilling operation, or for slope stability or rock mass rating classification. The first thing you can do with the result from this module is that you can enhance or optimize your blast design. The knowledge of joint orientation, the spacing, and the maximum persistence will help in designing your boarding, in positioning your spacing, and in also helping you to, select the best direction to better optimize your energy utilization. Then it helps in improving your energy confinement. Proper mapping will ensure explosive energy is not wasted through open joints or weak planes. Sometimes when the joint is too weak, you might lose some of the energy through the weak plane. Then it helps in controlling fragmentation. It helps in accurate charge placement. Above all, it also helps in calculating your combination ratio, which is the ratio between the 50% passing of the in-situ size and the 50% passing of the blast fragmentation size. Then in this new module, unlike the previous one, you have the output of rock quantity designation, which you can use in improving your blast module. Then apart from that, other property or other results from this module include the persistence information, the spacing rosette, and the orientation rosette, all apparent. So with this, you can also improve your failure prediction possibility, whether you're looking forward to plane failure or wedge failure or tumbling failure in the rock face. These are results that can help you. Then coming to rock mass rating, you have some of the parameters directly from this module, which will help you in rating your rock as quick as possible to make the necessary decision about rock bolting or concrete or shotcreting kind of approach in your optimization. Then going forward, I'm just going to show you an example of results from WipJoint. This is a result from a high wall. So in typical report of WipJoint, we include the in-situ block characterization, which shows the in-situ block and their size with a legend. Then you have the spacing result. You have the RQD, which is the rock quantities designation. Then you have the apparent joint orientation. As you can see, most of the joints in this plane is actually going towards this direction. So you see the dominant joint going towards this direction. So it helps you in selecting the direction of your hole and also knowing the possibility of comminution ratio that you'll be getting from this blast. After the blasting, you can also measure the fragmentation and also correlate the result with this particular plane output. Then other thing is the maximum persistence, which is the longest kind of joint that you have on the face, which is how continuous that joint is. So this will also help you in selecting the optimum budding and optimum spacing, such that you don't have the joints causing a loss of energy in between two block or two holes. So yeah, these are some of the example that you can see. Then you have the result of the in-situ block size, which gives you the D80, the D90, the X max, the D80, and you can also include other outputs, other D's values that you want from the result. So the software also shows you, that is the new module also shows you the maximum spacing between two joints on a plane of scan line, and the minimum, then the ratio. So these are things that you get. This is an example also in mapping a limestone wall, knowing fully where the limestone are very bedded. So you see more, or in this case, more of the joint orientation, that is the deep direction, the deep angle, the apparent deep angle is parallel, that is due to the plane status of this formation. So you can also see the RQD. The RQD of the limestone is slower compared to the RQD of the rock mass here, as shown in the other image. Yeah, regarding rating the RQD, as you can see on the screen, the RQD ranges from 0 to 100 typically, and 0 to 25 shows very poor rock, that is more than 27 joints per meter cube. Then you can see when it is 25 to 50, that's poor. Then 50 to 75. So in this case, the high wall is considered is to be in an excellent condition based on the RQD value. Then the limestone wall is rated to be between 50 and 75, which is fair. That is, you are looking at 13 to 19 joints per cubic meter. Then for the excellent, you are looking at 0 to 7 joints per cubic meter. So yeah, that's how to rate a typical RQD result for your bench or for your wall face. So from here, I'm going to be switching over to the software interface to show you how to activate this module. Yeah, thank you. Yeah, so just like WipFrag, all you need to do is to take the picture. You take the picture of the rock face with a scale on it. So you can take the picture in different ways. You can place the scale perpendicular. You can also take the picture in app. Like for example, you can see here I have this example where I put the scale. I use a tape rule as the scale reference. So you can currently you have to update to WipFrag 4.055. So you can import the WipJoint image directly from your desktop. If you have the picture on your desktop, you can also take the picture directly with your mobile phone, which imports directly into the software. So in this example today, I'm going to be making use of the high wall as an example. So here is the high wall image. So the same step with WipJoint, you set with WipFrag, you set the scale, you generate the edges with either deep learning or depending. If you want to go with simple, the deep learning makes things easy, less editing. So you can also edit, with the editing tool still available for WipJoint. So you make editing, then after you generate the next, when you are done with doing the editing with the next, so you generate the chart. So here on the chart, you can right click. If you can choose, if it is you can choose between different charts. So here you can see, if you want to see the WipFrag output, which is going to be showing you the in-situ block size. If you want to see the joint orientation and spacing directly, you want to see the output of the WipJoint all together in one report. So you switch to WipJoint here. So I want to go through that again. You right click on the chart. So you switch between charts. So if you want to see output of WipFrag, that is just the in-situ block size. If you want to still work with blast cast, I mean during blast design, not in this case, then you also have WipJoint, which is the output that we are having right now. So this is the typical output of WipJoint. You can edit the sieve for measuring the in-situ block size, which you also have the summary here. You have the joint, apparent joint orientation, and apparent in-situ block size. Then you have the persistence, that is the longest continuous joint in the plane. Then you have the maximum joint persistence, that is combination of all the joints that makes the dominant beam in this rosette. Then you have the spacing. The spacing rosette showing the spacing beam for different orientation of joints that you have on that plane. Then you have the RQD calculated based on the spacing information and other information from that plane. Then you have the maximum spacing, that is the maximum spacing that you have in between two joints on the same scan line. Then you have the minimum spacing value. Then you have the ratio of the minimum and the maximum. So yeah, this is a typical example of what you get from WipJoint output. You can edit these name. You can have two typical name line or something. You can edit that. So that's how you generate the output. Then let's generate the report. You can generate the report as PDF, just like WipFrag also. So if we generate the PDF in this case, as you can see, so it asks you where you want to save it. So I say I want to save it on my download. Then I have it saved on my download here. So I can bring out the output. So in this direction, the longest beam shows the dominant joint. So if you want to design your boarding and spacing, then this can help you in the positioning. Then for rock bolting or for other application for slope stability, you can use this orientation to make a necessary decision you want to make based on the apparent orientation of the joints on this plane. Then this is the apparent in-situ block size. Also, then this is the spacing between several joints as assets on that plane. Yeah, thank you very much. If you have any question, feel free to reach out to me. I will be happy to respond to your question. Also, I like to also mention that you can take the picture with scale. You can also take the picture with auto scale. All you need to do is if you can take the picture of the rock face, you can analyze it with WipJoint to get the orientation of the joints, the apparent orientation of the joints, the apparent in-situ block size, the spacing, the RQD, then the persistence of the joints. So thank you very much, and let me know if you have any question. Thank you.